Hello guys, welcome back to Maths Zone African Motives. We are still on our revisions. So this is our ZIMSEC exam that we are going to consider as part of our preparations for those who are preparing for the November exams and for those who are revising, the ones who wrote this exam. All right, so that was a June 2026 session that we are going to consider paper one, 2.5 hours. So make sure that you go through the instructions and information that you're given. All right. So the instructions to the candidates. So make sure, especially on the calculations, this is paper one. So show all necessary calculations, all right? And in terms of the decimal answers, which are not exact, should be given correct to three significant figures unless stated otherwise. So we're going to look into that. So this paper is marked out of 100. So for you to be able to download the question paper, I'm going to put this one on the comment section. So just check the comment section. All right. I'm going to put the link where you can download the question paper. All right. Or you can simply use the drive. All right. So if you check here under the Maths Zone African Motives from your YouTube, Maths Zone African Motives. All right. So if you enter here, I want you to check on this part. All right. Just click here. All right. Then inside, you can see this part where it's given YouTube, this part, and 13 more links. All right. So if you can consider those links, if you click this part of the links, you can see these are the links that you can access, all right, to join the membership and so forth. So for you guys, you consider this one, which is ZIMSEC. If you consider this one, the ZIMSEC studies, it's O and what A level. On this one, you are going to have, all right, the resources that you need, all the resources, textbooks, question papers. All right. So just click the link and it's going to take you through to the one for the O level. All right. So you go through the O level, you can download the PDFs that are inside. So you can use those PDFs for revision purposes for those who are using what PDFs, mostly you guys who are doing online classes, all right? So you can download all the PDFs. So click that link that you are seeing, this link that we are seeing in blue, this one. So if you click that link, it's going to take you through, all right? Let me just do it, all right? So if I click this one, it's going to take me through. All right. So here it's A level, O level. So you can what? All right. You can even click inside or download here. It's going to download everything on this download button that's going to, okay. Now if I do this, it's not showing, but if you see here, it's showing this download, or you can simply enter inside and see what I am having. So these are some of the, all right, resources that I'm having for you guys. So you can use these resources for what? Revision. So just check in within question papers and so on and so on. All right. So I'm going to update before I upload this video. I'm going to upload other resources. So you're going to see maybe some changes after that, because I'm going to upload or update other what resources inside. All right. So that is it about the drive. So this is your drive, this one for what? ZIMSEC studies. All right. Then for those who have been asking WhatsApp and so on, I need your WhatsApp number, this and that. So guys, there's no need for you to get the WhatsApp number. All we need now is to work with this platform. So I'm going to explain before I revise that question paper. All right, these are the platforms that we have. All right, we have the WhatsApp group. I hope this one I'm going to update Because there's another WhatsApp group that was automatically restricted. It was just restricted by the WhatsApp. I do not know. Meta, this what happened. So that WhatsApp group was restricted. All right. So we have other WhatsApp groups that you can use. I'm gonna update also these links on the WhatsApp, but there is this one. It's a WhatsApp group, and this one, grade 8 to 12. So this one, it is for those who are doing grade 8 to 12. But you guys, you can also join because we have similar topics with them, and also the link to the TikTok, Facebook, and so on. So you can use those links, all right? Use those, utilize those links, because if you are to use the WhatsApp, guys, most of the times I'll be busy and you might not get proper attendance, like, all right. So it is best for you to utilize the WhatsApp group, send your questions there, all right. Use these resources, all right, as part of revision. And for those who have got questions, all right, you have a question, you want to send the question, you can also participate, all right. Just like me, as I'm here, I can upload the videos, question papers. They say you can also do the same, but it is restricted that you can upload those pictures, all right? So using this community section, I've been referring to some of the videos. Use the community section. Do not use the WhatsApp. Just everything here, guys. We can finish. We can communicate using this community section. We can communicate as we are communicating on WhatsApp. So you just click that community. So it's going to take you through this part where you can upload what is in your mind, because here I did not sign in. You have to sign in. So I can see here I'm using a browser which is not signed in. If I was signed in, I can click on this part, all right? So it's going to give me an access where I can upload the picture, all right? So you can even write what is in your mind, like what we can see here, some of the other people have been writing here. Say, please do March N4 Mathematics 2026 paper, all right, with a special focus on question what 4 and 5. So you see, you can upload from your side. You can write from wherever you are on this channel. You can participate on this channel. So it is also important, especially for those also who are teaching, because we've got teachers also under Maths Zone African Motives. So for those teachers who are there, maybe you're teaching other subject, you can also participate on this channel by posting your lessons, all right? You can even post, this is lesson 1, this is lesson 2, this is lesson, post and have your details under that. I'm giving you that permission to do that, so that even access to the classes for those who are having online classes, you can even post and market your online classes under that platform, all right? For students, you can post your questions there. It is in form of a picture. You can post your question there. Then the teachers who are there, let us also participate in replying those comments, not just marketing your stuff, but but also replying to the comments that are there, that is also participating under Maths Zone African Motives. So this is what you have, guys. I'm going to go through the question paper. Like I said, you can upload, like you can see this one. It is a picture. Someone uploaded this. Hello, sir. Can you please help with that question, power machines, this? So you can do the same thing. So I simply have to upload the link. You click that link to the what? To the solution of that question. So as we are participating on WhatsApp, I want you guys to participate more here on this platform, not on WhatsApp. All right. So using this community section, you can participate, guys. You can be part of what? Part of the channel. So that is what I want you to do. So we are going to look into that as we are moving on. All right. Your requests must be here, not on WhatsApp, but on this platform. Let us finish everything using what? The community section. So let us go through the question paper that we are going to revise. As I said, we have got our paper 1, and on this paper, all right, you had the questions, the first part. All right, so remember here, no calculators. We are not allowed to use calculators for our paper 1. So answer all questions. 1, express 31,6824. All right, so you're given 31,6824. Correct to three significant figures. So these are important numbers considering 1 to what? To 9. 0 is taken as part of significant if it is between what? The whole numbers. So here we're talking about 1, 2, 3. So this 8 is going to round off. Is going to change this into a 7 since 8 is greater than what? Is greater than 5. So that was going to be 31,7. We are done. So we've got 1, 2, 3. Then to 2 decimal places on this part, 2 decimal places, we are focusing about these values that are after the comma, decimal places after the what? After the comma. So after the comma, you count 1, 2. So is this 2 going to change 8? No. 2 is less than what? Is less than 5. So it's not going to change. So we're going to consider this part as it is. And these ones will be what? Will be zeros. So that's 31,68. 2 cannot change that 8, all right? Then another one, it was to the nearest 10. So to the nearest 10, you consider the units and what? The tens concept. So this is unit, and this is what? 10. So 10 here, the unit, which is 1, cannot change this 3. 1 is less than what? Is less than 5. So it is going to be 3. The 1 is going to change into a 0, comma. All these will be zeros. So that's what? That's simply 30. So to the nearest 10, that was going to give us what? That was going to give us a 30. Okay, so this is how you can simply attempt such typical questions. 2A, we are given to convert this number that we are given in base of 2 to a number in a base of what? 5. So from base 2 to base 5, we can do this by converting to what? To base 10. Then from base 10, we can convert to what? To base 5. So that is how we can simply consider. All right, so this is what we're given, 1, 0. That's 1, 0, 0, 1, 1, base 2. So to base of 10, we are going to do this by raising this in the powers of what? In the powers of the given base. That is the base of what? 2. So in powers of what? In powers of 2, that's 2 to the power of 0, to the power of 1, to the power of 2, to the power of 3, to the power of 4, each number that you're given. So this is simply a multiplication that you're going to consider. That is 1 times 2 to the power of what? 4, plus this one is going to be 0 times 2 to the power of 3, plus 0 times 2 to the power of 2, then 1 times what? 1 times 2 to the power of 1. Then we have got 1 times 2 to the power of 0. So take note, guys, any number that is multiplied by 0 is what? A 0 there. So meaning to say, just going to consider the first part and this one and this one. 2 to the power of 4, that is 16, and multiply to 1, that was going to give us a 16, plus this, plus 2 to the power of 1, that's 2, times 1, that's a 2 plus 2 to the power of 0, which is 1 times 1, that's a 1. So you add 16 plus 2 plus 1. So that's 18 plus 1, which is 19. So that is 19 in the base of what? 10. But the answer is needed in the base of what? In the base of 5. So from base 10 to any other base, you can do that by dividing by the base. So that is to base of what? To base 5. So to base 5, you're simply going to divide by what? Divide by 5, noting the remainders. Noting the remainders. So that is the concept. So you divide by the given base that you are to consider the base of 5. So 19 divide by what? By 5, noting the remainders. So here we are going to have this column of the remainders. 19 divided by what? By 5. That's going to be 15 into 15 3 times. So 5 times 3, that's a 15. Then 19 minus 15, that's what? 4. So we have a remainder of 4. You do the same, divide by what? 5. 3 divided by 5, that's a 0. Remainder what? Remainder 3. So that's 3 becomes the remainder. So from the bottom going up, that is, you have your answer in the base of what? In the base of 5. So that was going to be 3, 4, base of 5 from the bottom going up. So that is what? 3, 4 in the base of 5. That was our final answer. So as we can see, that is how we can simply work out such typical questions. All right. Then B, you are given simplify. This was in the base of 5. So guys, whenever you are having these questions, can you have clear questions? All right. So that was the answer is needed in the base of 5. 4 to base 5 plus what? This is addition. 1, 3 base of 5. You are adding. So simply add 2 plus 3. That is 5. So 5 is equal to the base. Whenever you've got a number equal to the base or more than, it is equal or more than the base, you are going to divide by the base. So we divide by 5, which is what? Which is the base. 5 into 5, that is 1, remainder 0. So the remainder on our answer here, so right? So we are in the base of what? 5. The 1 here, we're going to give it on the other column. So we add 4 plus 1 plus 1, which is what? 5 plus 1, that's 6. So 6 is more than the base. So we're going to divide 6, divide by what? By the base. 5, that is 6 divided by 5, that is 1. Remainder what? Remainder 1. So the remainder on the answer, then this one, we are going to give it to the next column here. So that's the 1. 1 plus what? Simply these are what? Zeros now. So 1 plus 0, that's a 1. So 1 is less than the base. We can simply write that one as it is. You cannot write here on the final answer anything that is equal or more than the base. You cannot have that. So whenever you've got any number equal to the base or more than the base, that's where you're going to divide by what? You simply divide by the base, noting the remainder. So the final answer was going to be 1, 1, 0 base of what? In the base of 5. Direct as it is, this one you can simply consider direct. Number 3, the set S is such that S is representing a square, rectangle, equilateral triangle, a kite, trapezium, a parallelogram, all right? So here we've got a square where all sides are what? Equal. Then we've got a rectangle where opposite sides will be equal. Then we've got an equilateral triangle where all sides are equal. Then we have got a kite in this case, all right? So a kite, that's when the adjacent sides are the ones that are what? Equal adjacent sides. Then we've got a trapezium, which has got one pair of what? One pair of parallel sides. So a trapezium, it is about one pair of what? Parallel sides. And we're gonna consider the perpendicular height. Then we've got a parallelogram where all sides where opposite sides are parallel and what? Parallel and equal. Opposite sides being what? Parallel and equal, right? So these are the shapes that are representing the set S. So from that set S, write down the name of the shape which has a rotational symmetry of order 3. The rotational symmetry, how the shape is rotating along the what? The plane, 360 degrees. So when you are given this, remember from the polygons, when you consider the rotational order, when you have got regular polygons, for regular polygons, the number of sides simply represents the order of rotational symmetry as well as the lines of symmetry. So there is a regular polygon here, an equilateral triangle. It is a regular polygon. All sides are equal. So that one has got an order of what? 3. 3 sides. Number of sides is the order and also the lines of symmetry. So that one, the best answer was going to be an equilateral triangle. All right. So that is the best answer that you're going to consider. Right. Is there another one that has got 3? No one. So the other one, B, rotational symmetry of order 2. The order 2 and exactly 2 lines of symmetry. So take note here, exactly 2 lines of symmetry. Because the order 2, the one that has got rotational order of 2, all right, we can consider a parallelogram, all right, and a square, and this rectangle that we're given. But exactly 2 lines of symmetry. This parallelogram is going to be actually 1 if you consider that. So here, the best answer here is going to be a what? A rectangle. Line of symmetry 1, all right. In this case, this is another line of what? Another line of symmetry that you're going to consider. All right. Then this is what you have. If you're given a parallelogram, all right, if you're given this one, it is going to be like this. It is a line of what? A line of symmetry. This one, and also this one, it is a line of what? A line of symmetry, because this part is going to cover other part that you're given there. So it is a what? Line of symmetry again. So this is the case, but you are limited now on the order of rotational symmetry. So the best answer is going to be the rectangle, because here it is order of 2 and exactly 2 lines of symmetry. So the best answer here is going to be a rectangle. All right. So that is what you are given on this part. And for one line of symmetry, let's consider one line of symmetry here, which is going to be the best here is a kite. One line of symmetry, because here there are 3, here there are 4. So here it is a kite. If you divide it like this, it's going to be divided into 2 equal parts. So this will be into 2 equal parts. This shape 1 and this other shape of a triangle there. So that is, you can divide it into 2 equal parts once along that line. So it is the one that has got what? One line of symmetry, which is what? A kite. So the best answer here was going to be a kite. So this type of a question, it is all about knowing the properties of the shapes. Just revise along the properties of the shapes. Number 4, express this as a single fraction, all right? As a single fraction in its simplest form. All right, so let us do the factorization. Here we can factor out the highest common factor, which is 2. So that was going to be 1 over 2. Then 4 divided by 2, that's 2x. 2 and 2, that's negative y that you're going to have, minus y over 4x squared minus y squared. That's a difference of 2 squares. This is a perfect square, also a perfect square. So simply determine the square root of this and the square root of this. So that's 2x, the square root of y squared, that's y. So one bracket is going to subtract another bracket is going to add from the concept of what? A minus B into A plus B, the difference of two squares concept. So that was going to be 2x minus y and 2x plus y on the other hand. So this is what you have. All right. So having these two brackets, and here we have got 2 and 2x minus y. These two same. So we can simply make sure that the denominators are the same so that we can simply combine the numerators. So there are so many ways of doing this, right? Since we have got 2x plus y here, we are going to bring it this side. So it's going to be 2x plus y over 2x plus y like this. So bring it this side. Then this side, we do not have the 2. So we are going to bring this 2 this side. So it is going to be simply 2 over 2. All right. So that's 2 over what? 2 over 2. So this is what you're going to have. As we can see, the denominators are the same for the first fraction and for the second one. So we can simply combine this under that denominator, 2x minus y into what? Into 2x plus y. The common denominator as it is. So you combine the numerators from the first fraction, what we have 1 into what? 2x plus y. So it is 1 into 2x plus y minus 2 times what? 2 times y, which is 2y. So that is it. Here we can simply expand the bracket. 1 times 2x, 1 times y, that's y minus 2y. Everything over the what? The denominator, 2 into 2x minus y into 2x plus y. So this is it. Collecting the like terms, this is y and y. These are like terms. So we can consider the part of y separately. So what are we going to have here? That is going to be 2x1 minus 2. That's minus 1. So that's minus 1y, which is what? Minus y. Everything over 2 into 2x minus y, 2x plus y, and like this. So we can see that the numerator 2x minus y and the denominator, this one, 2x minus y, are the same. So we can simply divide this and you remain with a 1 in the numerator. So definitely here, you're going to obtain, it was going to be 1 over what? 2 into this bracket, 2x plus y like this, all right? So you can leave your answer as it is, or you can even multiply by 2 inside the bracket. It is one and the same, all right? So this is your simple subtraction, all right? So here, instead of doing this, there are so many ways, guys, considering subtracting of the fractions, addition and subtraction of these fractions. There are so many ways that you can simply do this, all right? So another way, you could have just considered finding the LCM or the LCD of the given what? Denominators. So from these denominators, we can consider, so that's another way you can consider the LCM or the LCD, which is we have got the LCM, we have to take all the terms or the brackets, all right? So 2 is going to be part of the LCM, then 2x minus y, all right, and 2x plus y. So you do not repeat the 2x minus y like this one. So this is our LCM. So this whole part is going to be over that LCM or the LCD, which is 2 into what? 2x minus y into 2x plus y like this. So this is how we can simplify. Divide the LCM, all right, by what? The first fraction, the term or this bracket in the denominator. So it's LCM divide by this. Your LCM, this one, divide by what? By 2 into 2x minus y. So definitely this part and this part was going to cancel. You remain with what? 2x plus y. So you're going to remain with 2x plus y. So it's 1 times 2x plus y. Minus, you do the same. Your LCM divide by the what? The denominator of the second fraction, which is 2x minus y, 2x plus what? 2x plus y. You divide, this was going to cancel, this one was going to cancel. You remain with what? You remain with 2. So that is 2 times what? times y. Just like that. So this is how you're going to simplify if you were considering the LCM. Then from there, then simply expand the bracket here, 1 times 2x, 1 times y. So that's 2x, 1 times y, that's y. Minus 2 times y, that's what? That's 2y. Everything over 2 into 2x minus y into 2x plus y, like this. So this is what you're going to have, collecting the like terms just like before. You can see that this stage is simply the same as before. So that was going to be 1 here. Then we've got 2x minus, that's 1 minus 2, which is what? Minus y. Over what? 2 into 2x minus y, 2x plus y, like this. Okay, so let us cancel this one and this one. You remain with the 1. So that was going to be 1 over 2 into this bracket of what? 2x plus y, just like that. So this was going to be our final answer, just like before. So we can see that simplification is actually in our hands. We can perform it the way that we understand. All right, a model greenhouse is made to this scale on question number 5. 1 is to 200. 1 is to 200. A scale representing what is on the map and what is on the actual ground. Remember, what is on the actual ground, which is given in centimeters to this one, also in centimeters. All right. That's the presentation that we're given, which we can play around to convert these centimeters on the actual ground to meters, depending with the question that you're given. So A, calculate the length of the model in centimeters. So the model is the one that you have on the map. On the map, that's where we've got what? The model. If the actual length that is on the actual ground of the greenhouse is 7,8 what? Meters. So as we can see, this is in meters. So we can change our scale to meters as well if we want to write a centimeter on the model or on the map. 1 centimeter is going to represent how many meters from the 200 centimeters that you're given. Remember, a meter is equal to 100 centimeters. So in 200 centimeters, how many meters? Simply divide by what? By 100. So that is simply what? 2 meters. We can convert to have the relationship between what is on the map and what is on the actual ground in meters. So if we have this in meters, it will be easier for us to answer this question. Yes, you can use the centimeters. I'm not saying it's wrong. You can use the centimeters, then convert those centimeters on your final answer. That's another way. Or you can use what? Direct in meters to say 1 centimeter on the map, which is for the what? For the model, represents 2 meters on the what? On the actual ground. So if on the actual ground we are given 7,8 meters, that is what you're given here. If we are given 7,8 meters on the what? Actual ground, how many centimeters do we have here on the what? On the model? So that's definitely going to be what? More. 7,8 compared to 2, that's more. So that's 7,8 over what? Over 2 times what? Times the 1 centimeter. So this is what you're going to have. Simply divide 2 into 2, 1 into 7, that's 3 into 6. So 7 minus 6, that's a remainder of 1. So that's comma 2. All right, you have a remainder of 1 here. So 2 into 18, that's what? A 9. So it's going to be 3,9 times 1, which is 3,9 centimeters. All right, so that was going to be our final answer in centimeters. All right, simply use that scale that you are given. Like I said, you can as well work with centimeters as you were given to say it is 1 centimeter on the map to 200 what? Centimeters. So if we are given this 7,8, you have to convert it to centimeters, multiply by 100, you have that as 780 centimeters. Then You have your answer in centimeters, then convert it. So you see, guys, it will maybe something else, but you can do that. I'm not saying it is wrong, but this was going to be easier. Just use the scale already in what? In meters. So that is an easier way to work out that. All right. Then B, on the model, the base area. They are talking about area. The base area. So once you are referring to the area, it means from what we are given, this was the ratio that we are given of length. What is on the ground to what is on the length? This is length. 1 centimeter is what? The 1 centimeter is to 2 meters. It is the scale factor, this one. It represents the scale factor from length. So when you are given area, you must have the area factor, which is the square of what? The square of the scale factor. So our area factor, we simply have to square the scale factor. 1 centimeter is to 2 meters. We square it. So it's going to be 1 square centimeter is to 2 squared. That's 4 square meters. So this is what our area factor, the one that we can use whenever they are referring about what? About area. So they are saying here, because here it is simply, what was here, guys? The model as it is before. This is your model, the map, and this is what? The actual, what is on the actual what? What is on the actual ground. So they are saying on the model, the base area is 70 square centimeters on the model. So from this relationship that you're given, a square centimeter, if it represents 4 square meters. On the model, remember this is our model, the 1 square meter. So on the model, we are given the area as 70 square centimeters. Calculate the actual base area of what? The greener. The actual is the one that we need. So this is what? The part of the actual, remember? So what will be the actual area here? We do not know. In what? Square meters. So this is supposed to be in what? Square meters. So what is going to be the area? So it's going to be more from comparing these two. 70 is greater than 1. So simply 70 over 1 times what? That. So the bigger value as it is more. 70 over 1 times what? Times 4 square meters. Our answer in square meters. 4 times 0, that's a 0. 4 times 7, that's going to be 28. So that was going to give us 280 square meters. That's the actual area that you're going to have on the what? On the ground. All right, just like that. All right, let's consider question number 6. We are given a rugby team, all right, plays 40% of its matches at home. So meaning to say another one is what? Away, the remaining one from 100%. If 40% is home, so minus 100 minus 40, 60% is going to be what? Away. They win 70% of their, 75% of their home matches. From the home matches, they win what? 75%. Meaning to say to lose, it will be the remaining from 100%. 100 minus 75 will be what? 25% to lose, whilst they are at what? At home. All right, so this was to complete. All right, so guys, here let us just complete. So the home, they gave us the percentage playing at home, 40%. So these are decimals that we are given. They simply divided 40 over 100, which is what? 0.4. So the same thing away, it's what? 60%. 60 over 100, which is what? 0.6. Or simply consider, guys, whenever you're given the diagram like what we are having here, they gave us a diagram. So you can simply consider this condition that the probability of each branch is supposed to give us a 1. Each branch must give us a 1. So to complete this diagram, simply subtract 1 minus what? 0.4. 1 minus 0.4, this one. That's 0.6, which is the same answer. The same with this one is 0.75. 1 minus that. 1 minus 0.75 is what? 0.25. This one is what? 0.55 from 1. 1 minus 0.55 is going to give us what? 0.45. So we can simply complete the diagram that way. Each branch is supposed to give us a 1. Or you can consider the information as you are given to say the one is 75%. The other one is going to be 25% loss. The same thing. The same thing here. And only 55% of their away matches. So away, the win is 55%. So the remaining from 100, 100 minus 55, that's what? 45%. You can do the same or simply subtract from what? From 1 as they are given as decimals. So you've completed the diagram. That was 2 marks for that. All right, then let us consider the questions. That is the part B. Find the probability that the team wins a what? A match. Just to win a match. So to win, they can do that. To win, there's a win here. So you consider the branch where there is a what? A win. There's also a win here. So they can win whilst they are playing at home. So it can be home and win, or away and what? Win. So that was the condition of what we are given, the probability to what? To win. It is they are playing at home and they win, or they are playing away and they do win. This is the condition that we are simply referring to. All right. So home and win. It simply means home is what? 0.4. The win is what? 0.75. You multiply along the branch. 0.4 times 0.75. Then plus away and they do win. So they are away and they win here, right? So that's 0.6 and what? 0.55. So those are the ones that you're going to multiply, 0.6 and 0.55, just like that. So multiplying these two, 0.4 times 0.75, all right, times 0.4. 4 times 5, that's 20. Then you're going to have a 2. This is what? 28 plus 2, that's 30. Our main decimal place is 1, 2, 3. So that's 1, 2, 3. So this is going to be 0.300, which is what? 0.3 plus, all right, this one 0.6 and 0.55. Simply multiply 0.55 by what? 0.6. 6 by 5, that's 30. We're going to have a 3 here. 6 by 5, that's 30 again. Plus 3, that's what? 33. Our main decimal place is 1, 2, 3. 1, 2, 3. So it's going to be 0.330. So that's 0.33. So this is 0.33. Then simply add 0.3 plus what? 0.33. Remember, the comma is supposed to be in a line. So this is going to be a placeholder 0 there. So 0 plus 3, that's a 3. 3 plus 3, 6. 0 plus 0, that's a 0. So that's 0.63 as a decimal. So you can have it as a decimal 0.63 or 63 over what? 63 over 100 as a fraction. Probability can be given as a decimal. So you can just use the decimals as we have here on the what? On the diagram. All right. So that was it on question number 7. There is an any-sided shape, which is a regular polygon. All right. Regular polygon, number of sides, the size that you'll be given will be what? Exactly the same. So it is such that its interior angle is 5 times the exterior angle. So here they are giving us the relationship between the interior and the exterior angle. All right. Then from there, calculate the size of each exterior angle. All right. So remember, from the interior and exterior angle, this is it. If this is exterior angle and this is our interior angle, these two add up to 180 degrees. Interior plus exterior angle is equal to 180 degrees from the properties of what? A straight line. They form a straight line. So we can use that relationship. So we can let the exterior angle to be equal to x, since the interior angle is given in terms of what? In terms of the exterior angle. So they are saying interior angle is 5 times the exterior, 5 times. So that's 5 times what? 5 times x. 5 times that. So this is a relationship which is equal to 180 degrees that we can use to find or to calculate the size of each exterior angle. As the exterior angle is represented by x, we can form an equation 5x plus x is equal to 180, as x what represent the exterior angle. So we can solve this from this relationship. Interior plus exterior equal to 180. They form a straight line. So this is simply 1. So add like terms. That's 6x is equal to 180 degrees. Divide by 6 by 6. So that was going to give us the value of x. That's 18 divided by 6, which is 33. And this one is going to give us a 0. So that's 30 degrees. So each exterior angle was going to be what? Was going to be equal to 30 degrees, the value of x. That's what? 30 degrees here. All right, so that was simply what we are given. And on the other hand, the number of sides of the polygon. So for number of sides, we can use the exterior angle. Remember, this polygon is what? Is a regular polygon. So all exterior angles, these exterior angles that we have outside of this regular polygon, they add up to 360 degrees. So we can use that as what? As for calculating the number of sides, because we know that there will be each 30 degrees. This one was going to be 30 degrees. This one also 30 degrees. So out of 360 degrees, how many exterior angles do we have? They represent what? The number of sides. So number of sides from the total 360 degrees divided by what? Each exterior angle here. Each exterior angle that we are given is going to be 360 divided by 30 degrees. So that's going to be what? 312. So that's 12. So meaning to say this polygon has got what? 12 sides. We can work it from exterior angles. Yes, you can find the interior angle to say, okay, from there are so many ways, guys, all right? There are so many ways to say this is the interior angle. So 180 minus 30 is going to give us 150 degrees. So since it is a regular polygon, n minus 2 times what? 180 degrees. This is the sum of the interior angles. Then divided by what? Divided by each interior angle. All right. I mean, divided by the number of sides. Since it is a regular polygon, it is going to give us each interior angle. All right. So each interior angle is what? 150 degrees. So you have formed an equation from what? From the sum of what? Interior. So this is the sum. This is what? Number of sides. This is what? Each interior angle. So let's say simply cross multiply. So that's another way. So n minus 2 times 180. Let me just ignore these degrees, or let me just leave it. N times this 150 degrees times n. So we can simply divide by, or simply reduce this one, all right, by 10 by 10. That's going to be 15. So 18 times 2, that's 18n. 18 times n, I mean, that's 18n times negative 2, that's negative 36. All right, which is equal to 15 times n, that's 15n. So to solve for n from this one, it is going to be, to the other hand, 18n minus 15n is equal to 36. So that is it. 18 minus 15, that's 3n equal to 36 divided by 3 by 3. So n is equal to what? To 12. So many ways that you can actually play around. So that is 12 what? 12 sides. So many ways, all right? So it was just a matter of playing around with what you're given. So this is it from the given information. Number 8, all right, 8a, solve this inequality. All right, so many ways again to solve such an inequality. All right, so here 2x plus 3 is greater than minus 5, but less than what? Less than 1. So I can solve this direct on the diagram, taking the 3 to this other side and also this other side. So here it's going to be minus 3, minus 3. All right, so minus 5 minus 3, that's what? Minus 8 is less than 2x less than 1 minus 3. This is negative 3 here. So 1 minus 3 is going to give us what? Minus 2. Divide by what? 2. 2 is a positive, so it's not going to affect our inequality sign. So that was going to give us x is greater than minus 8 divided by 2, that's negative 4. 2 and 2 cancels, that's negative 1. We have our answer. And give the solution in form of this, in this format where these are integers. We could have just solved it direct as it is like this, all right? Or you can separate them, all right? Another way that we could have solved was simply to separate the middle term, the middle expression, this part of 2x plus y, these two inequalities separate from that 2x plus 3. So it's minus 5 less than 2x plus 3, this one. Then we start with the 2x plus 3 to this inequality. So 2x plus 3 is what? Is less than 1. So there are two inequalities that you're going to solve, all right? So the 3 to the other hand is going to be a negative. So minus 5 minus 3 minus 8 less than 2x divided by 2 by 2. So that's it. X is greater than minus 4. The same thing, the 3 to the other hand is going to be a negative 3. So 2x is less than 1 minus 3. That's negative 2 by 2 by 2. So x is less than what? Negative 1. So in this form, a is supposed to be the smaller value. So comparing minus 4 and minus 1, minus 4 is the smaller value. So x is greater than minus 4. But the same x is what to minus 1? It is less than negative 1. So that is what you're given. All right. Then on B, write down the largest integer x, which satisfies this inequality. As we can see, this inequality is the one that we solved here before. And this is our final answer. So what is the largest integer in between this? All right. We can use our number line concept. This is negative 4. And we've got negative 1 here. 0 is going to be on the other hand. So minus 4 and minus 1, they are not part of the solution, right? From the sign that you're given. If it was greater than or equal to, or less than or equal to, and greater than or equal, that's where we shed on this part or this other hand. So here we're not going to shed. We do not have what? The equal to this part. So these integers, minus 4 and minus 1, they are not part of our answers. So we have minus 3 and minus 2 in between. So the largest integer closer to what? To 0 is what? Minus 2. Considering negative numbers, the larger value, being large in terms of negative numbers, is what? Being closer to what? Closer to 0. Closer to 0. So that is the concept. So the number closer to 0, the integer, is what? Negative 2 from our solution. So that was the largest integer that was going to satisfy the given solution. All right. Then number 9, given this, all right, m over n is our standard form. Simply divide m, 6 times 10 to the exponent of 3 over n. This is a negative here. So that's 8 times 10 to the exponent of negative 6. Divide the numbers separately, 6 and what? 6 and 8. So 6 divided by 8. This one is direct, guys. 2, that's 3 over 4. 3 over 4, that's 0, 0.75. Remember your decimals, all right? 3 quarters, 0, 0.75. Then divide the bases, this part of 10 to the exponent of 3. So that's 10 to the exponent of 3. We are dealing with what? Same bases. So we are going to subtract the powers. So that is going to be 3 minus 6. You subtract, what are we subtracting? Minus 6. So negative, that was going to give us a positive. So that's 0, 0.75 times 10 to the exponent of 3 plus 6, which is what? Which is 9. So this number, the 0, 0.75 is not in standard form. So writing our answer in standard form, we have to convert this to what? Standard form. 0, 0.75 in standard form. 0, 0.75, it is going to be between 7 and 5. So that's what 7,5 times 10 to the exponent of a negative 1. All right, since we've got the 0 comma there, we're starting with a 0. So it's going to be a negative exponent. We moved only 1 comma, remember? So multiplying to what? 10 to the exponent of 9. Already we have this one. So here, what are we going to have? We are back multiplication, where there we are considering what? The same base. Considering same base under what? Multiplication, you add the exponents. So that's 10 to the exponent of negative 1 plus 9. You add them. So minus 1 plus 9 is what? 8. 9 minus 1, that's 8. So it was going to be 7,5 times 10 to the exponent of 8. So you simply combine these, all right, by adding, since you are multiplying same what? Same bases. So that is the consideration from what we are given, having our answer in what? In standard form. It is very important that you're given questions under standard form. You have your final answers in a standard form unless stated otherwise. All right. Then this was B. It was the cube root of what? N. That is the cube root of N. Our N is what? 8 times 10 to the exponent of negative 6. 8 times 10 to the exponent of negative 6. We can determine the cube root of 8. That is the number multiplying itself 3 times is what? 2 to give us 8. So the cube root of 8 is 2 times the cube root of this 10 to the exponent of negative what? 6. You simply divide 10 to the exponent of negative 6, divide by the number inside the root, that power. So divide that power by what? Negative 3. So that's by 3. Negative 6 divided by 3 is what? Negative 2. So that's times 10 to the exponent of what? Negative 2. Direct as it is, you have your answer. All right. So that is what you're going to have. All right. Number 10, by selling a drink. For this, we have got our selling price. A shopkeeper makes a profit. So there is a profit, all right? And find the price at which the shopkeeper should sell it to make a profit of. So this is the second condition from what we are given. This one is our second condition. So let's work out from the first condition that we are given. Can we determine the cost price here? Can we have the cost price? Because we are told by selling, we have got the selling price. So we have a profit of what? Of 30% here. So remember, the cost price is always at what? 100%. So meaning to say, the cost price, we do not know it using the first what? Condition. We do not know the cost price, but we know it is always at what? 100%. Given the selling price of what? $78, which is making a profit, which is from a profit. So there's a profit of 30%. From the cost price, which was at 100%, there is a profit you add to the 100%, because the selling price is more. We have added a 30% this profit. So it will be at what? 130%. All right. So it is at 130%. So what is the cost price from the first condition that we are given? All right. So the cost price from 100% comparing these two is going to be less. So that's 100 over what? 130. 100 over 130 times $78. Let's consider the cost price first. All right, so let's see, this is gonna cancel. All right, and that is simply divide. All right, 78 divided by what? Divided by 13 is gonna be 6 times. This one, 78 divided by 13 is gonna be 6 times. Then 6 times 10 is what? 60. So that's $60. All right. So from the given condition, that first condition, $60 is our cost price. All right. So we are being asked to find the price at which the shopkeeper should sell. We are supposed to find the selling price given the cost price, because the cost price is our initial value. This is our initial value that we are having. So it is not going to change. It is going to be taken from that initial value, which is what? $60. So using this condition, ignore what we had from the first condition. Let's work on the second condition. Your cost price is $60, which we know it is always at what? 100%. So what is our selling price in order for us to make a profit of 25%? We simply use the same proportion just like before. The cost price, we know it this time, the $60, that's our cost price, which we always equate to 100%. So now we have made a profit of what? 25%. To make this 25%, we have to add the profit. So you add to 100, which is 125%. What is the corresponding value, which is our selling price? So definitely it's more according to 125 compared with what? 100. This value is going to be what? More. So that's it. So 125 over this 100, then multiply to the what? To the price, $60. That was going to give us the selling price from what we are given to make a profit of 25%. All right, so let's play around, cancel this. All right, this is a 10 and a 6. You can even multiply 6 times this, that's 30. 6 times 2, that's what? 12 plus 3, 15. 6 plus 1, 750 over what? Over 10. All right, so this cancels, you remain with what? 75. So that was going to give us what? $75. Okay, so this is the condition. You're going to obtain $75 from what you're given. Okay, so that was it. Then B, we are given here that value added tax at the rate 15% is added to a marked prices of all articles in a shop. All right, an article is marked $60. Find the price of the article, including VAT. So VAT here is an added tax. Let's simply calculate that VAT, which is 15%. It is 15% of what? The marked price. 15% of all articles, which is what? The marked price, $60. This is our VAT, the exact value, the money that is going to be added, the amount to be added to what we're given. So you can simply play around, cancel this, 6 times this, that's 30, 6 times 1, that's 6, plus 3, that's going to be 9 over what? Over 10. So cancel, that's going to give us what? $9. So our VAT in terms of the amount is $9. So the price including VAT. So the price including that's add that, including what? VAT. VAT, it's added tax. Added, you must add it. So you add it to the what? To the marked price, which was $60 plus what? That VAT of $9. So that was going to give us what? $69. So that is our final answer here. It was going to be what? $69. All right, so you can just consider this way, $69. Okay, then number 11 on A, simplify this A item 1. All right, simply multiply, then add 8 plus 1, that's 9 over 4, minus multiply, add 3 plus 2, that's 5 over 3. So you can consider the LCM or just interchange to have the same LCM, to have the same denominator. Just interchange these. 3 multiplies this side, so you multiply by 3 over 3. 4 multiplies this side, so you multiply by 4 over 4, just like that. So this is going to give us what? 9 times 3, that's 27. 4 times 3, 12, minus 5 times 4, that's 20. 3 times 4, that's 12. As we can see, the denominators are simply the same. So simply subtract what? The numerators. 27 minus 20, which is what? 7. So that was going to give us what? 7 over 12. All right. Or you can, guys, there are so many ways you can just have it as it is. 9 over 4 minus 5 over 3. You find the LCM of the given denominators, which is what? 12. 12 divided by 4, that is what? 3. Then 3 multiplies the numerator. So that is 3 times 9 minus 12 divided by 3, that is 4, and 4 multiplies what? The numerator, which is 5. So that was going to be 9 times 3, 27, 4 times 5, 20, over what? The denominator, 12. So 27 minus 27 over what? Over 12. So as you can see, the same answer just like before. This was going to give us what? 7 over 12. All right, divide. Here, this is 1 over 3 divided by this. Simply introduce multiplication, and we know that we interchange the second what? Fraction. So that's times 5 over 4. So you can multiply the numerators together, denominators together, since we cannot cancel. 1 times 5, that's 5. 3 times 4, that's 12. So that was going to give us what? 5 over 12. All right. Express this as a percentage. Simply multiply to what? 100%. 25 over 40. Over 40 times 100%. So that was going to cancel. All right. 0 and 0. Then here you can try to reduce by 2. That's 2 here by 2. That's 5. All right, and what can we do? We can simply multiply 25 times 5. 5 times 5, that's 25. 5 times 2, that's 10, plus 2, that's 12. Over what? Over 2. 2 into 12 here, that's going to be into 10, 5 times. Is that so? So into 12, that's 6 times. I mean, direct into 12, that's 6. All right, then 2 into 5, that is 2 into 4, remainder 1. All right, so that's into 10, 5. We consider that as a percentage. All right, so that was the concept. So this is 62.5 percent that we are going to have. All right, number 12, we are given a tank. All right. Water, a full water tank had 575 liters of water left. So this is the number, the amount of water, the volume or the capacity of what that is left. When a farmer used 3,865 kiloliters of water on irrigation. So the amount of water or the volume that was used, 3,865 kiloliters. Kilo, that's 1,000. So multiply by 1,000, that's going to be 3, 1, 2, 3. So it's going to be 3,865 liters. So this is what we have. So A was find the capacity of the tank when full. So remember, when full, it is before we used something, then there was another part which was left. So you simply combine what was left in the tank and what was used. That's the full capacity. What was left in the tank was 575. What was used, because this is in liters, also consider this one in liters. That's why you have to multiply by 1,000 for a kilo. So that's 3,865 liters. Liters to liters you can add. That was going to give you 4,440 liters. All right. So this is the amount. This is the capacity. I mean, when what? When full. All right. Then a bowl. So we've got 4,440 liters. All right. Then a bowl pumps 7,200. So this is the rate at which it is pumping 7,200 liters in what? In 1 hour. Find the time taken in minutes to fill up the tank when empty. So when empty, you have to fill up how many liters? Full until it is full. So it's gonna be the capacity divided by the rate at which you're pumping 7,200. So this is per hour. So this is gonna give us our answer in what? In hours. All right. So here cancel this, then reduce this. All right. We can reduce, and that's let's try by, all right, let's try by what? By 2. All right, 2 is going to be very small. Even 4, let's just try 4. All right, so it's going to be 4. That's 1, 4, 1, 4, 1. 4 here into 72. Let's just say 72 divided by 4. That's 18. Then 0 here, 180. So it's going to be 111 divided by 180. All right, divide by 180, which is going to give us 111. All right, let's look for a number that we can use. 3. Let's try 3. 3 here, 111 divided by 3. 3 into 11, that is going to be into 9. That is 3, remainder 2 into 21, that's 7. So 3 can work, all right? So 3 can work. That's going to be 37. 3 into this 18, that's 60. So we are going to have 37 over 60 hours. But the time is needed in minutes. 1 hour equals to what? 60 minutes. So whatever number of hours, if you want to convert them to minutes, you multiply by what? 60. So you're simply going to convert multiply by what? 60 to convert to minutes. 37 over 60 times 60 minutes. That is converting to minutes. This cancels. You remain with what? 37. So that was going to give us 37 what? 37 minutes direct as it is. All right. So that was the time that was going to be taken to fill up. All right. Given this, y is equal to 100 over x squared. It's just like y is equal to k over x squared. 100 is a constant, that numerical value. So state the type of variation, which can be written like this. All right. So that is inverse variation. Y and x are inversely related. When x is increasing, y is decreasing. So this is what? An inverse variation that you have to consider here. All right. Then from that relationship, calculate, all right, y when x is equal to 5. When x is equal to 5, remember, given this relationship, y is equal to 100 over x squared. So simply substitute into that relationship. Y is equal to 100 over x squared. All right. So our x is what? Our x is 5. So simply substitute in place of x. That's 5 squared. So y is equal to 100 over 5 squared. That is 25. 5 times 5. So y is going to be equal to 4. So that is the value of y that you're going to have. Then the value of x, just like before, x when y is equal to 4. Remember our relationship, y is equal to what? 100 over x squared. So this time we are given the value of y. So in place of y, you simply put 4. So 4 is equal to 100 over x squared. Find x. So cross multiply. 4 times x squared, 4x squared, 1 times 100, divide by 4 by 4. So that's x squared is 100, divide by 4, which is what? 25. So it is the same as before this one. So introduce the square root. The square root of any number is what? Plus or minus. So you can write x as plus or minus 5, but you can even have it as just 5 here, right? Or you can have it as what? Plus or minus 5. There is not an effect at all. So that was what we had. All right, considering number 14. All right, we are given here. All right, so this was part of question number 18. All right, so that is it. That is it, just like that. 2 marks there. All right, so they were given, this is our velocity in meters per second. That's our V 2010, 20. Here, this is 60, 70, our time in seconds. The diagram is a velocity time graph of a train which travels a distance of 880 meters in 70 seconds. In this total time of 70 seconds, this is the total distance that we are given. So we are given total distance of what? Of 880 meters in the time frame of what 70 seconds. All right, calculate the value of V. So guys, V is an unknown value. We can simply use that total distance because we know that the total distance can be obtained if we are to calculate the area under the what? Area under the graph. So we consider this is what? A trapezium, as we've got one pair of what? Parallel sides. So we consider the area of a trapezium as what? Distance is that distance is simply equivalent to total area under the graph. Area under the what? The graph. So that is the area of a trapezium. Remember, half of what? Half sides, half sum of these parallel sides, half of A plus B times the perpendicular height, which is equal to what? The total distance of 880 meters. So what we are going to have, A is what? The difference here between these 2 points, 20 and 60. So that's simply 60 minus 20, which is what? Which is 40. Then B is from 0 to what? From 0 to 70. So that's 70 minus 0, which is what? Which is 70. So H is the perpendicular height, the perpendicular height. So that's the distance here representing our V. So H is representing V. So that's half of what? A, which is what? 40, the difference, plus B, which is what? 70 times H, that's the value of V, giving us 880. We formed an equation that you need to solve for what? Solve for V. This is an equation that you have formed. So solve for V. I can simply add these two. That's half of what? 40 plus 70, that's 110 times V is equal to 880. Half of 180, that's into 10, 5, remainder 1 into 10, that's 5. So 55 times V, that's 55 V equal to 880. So we can simply reduce by 11 here. All right, let's try 11. That's going to be 5. 11, that's 80. So 5V is equal to 80 divided by 5 by 5. So V is equal to 5 into 8, that's 1. Remainder 3 into 30, that's 6. So V is what? 16. So this V here is what? 16, representing in what? Representing the meters per second. That's how we can play around with it. So that was our value of V. Then the acceleration here, the acceleration during what? The first 20 seconds, all right? Acceleration is simply can be calculated, all right, from the change in velocity, all right? Acceleration, simply change in velocity over the change in what? Time. So during the first 20 seconds, the change in velocity, it was from 0 to what? From 0 up to 60. So that's up to 16. So that's 16 minus what? 16 minus 0, change in velocity. Change in time from 0 to what? From 0 to 20. That's simply going to be 20 minus what? 20 minus 0. That's it. So 16 over 20 reduced by 4. That's 4 over 5. 5 into 4, that's 0, 0.8 into 80. So that's 0, 0.8 meters per square second acceleration. There are so many ways. Or you can simply calculate that acceleration from the gradient concept. All right. Acceleration can be calculated as gradient change in y over the change in what? Over the change in x. So during the first 20 seconds, you are referring these ones as what? As points. The first 20 seconds from 0 to 20, we are considering the gradient of this line. So this point is what? 0, 0 on the origin. Then here it's 20 versus what? It's 20 versus 16 as a point. So those are x values, x, y, x and y, x2, y2. You can write them like this. Though it's velocity and time, you can use those y and x that you are used to, all right? So y2, that's 16, minus y1, that's 0, over x2, that's 20 minus x1, which is 0. So that's simply 16 over what? Over 20. Just like before, you can see, guys, it is just like before. So we are going to obtain the same answer just like before, 0, 0.8 meters per what? Square second. All right. So many ways You can play around. This is your information, guys. Play around the diagram way that you understand, all right? Then another part, it was to find the retardation during the last 10 seconds. So retardation or what? Deceleration during the last 10 seconds. This is from 60 to 10. That is where we've got what? The last 10 seconds here. So the retardation or deceleration, it represents a negative acceleration. So you calculate first your acceleration normally, all right, as you are used to. During this, we know that as we are going down, we are going to have what? A negative acceleration. You can use that change in velocity over change in what? Over change in time. You're going to obtain a negative value, or you can use points. This is 60 corresponding to this point, which is what? 16. So it's 60 versus 16. This point here is 70 versus what? The velocity here is 0 on this horizontal line. We are on the what? On the starting point. So here it is the end point, velocity being 0. So using that same combination, this is x1, y1, this is x2, y2. So I can find my acceleration using y2 minus what? Y1 over x2 minus x1. Another way is simply the same. 16 minus what? 0, the y values. X minus x, 60 minus what? 70. So that was going to give us 16 over negative 10. That is a negative 1,6, all right, meters per square second. This is acceleration, but the question is asking us to find the retardation, all right, the retardation or what? Deceleration, which is negative of the acceleration that you obtained of negative 1,6. So negative of that is going to give us a positive. Negative times negative, that's positive 1,6 meters per square second. So that is your retardation here, 1,6, right? Meters per what? Meters per square second as a positive. All right, just like that. Number 15, given f of x. All right, from f of x, which is 6 minus x, find a f of 2. Simply substitute x, which is, this 2 in place of x, f of 2. 6 minus our x value is what? Is 2. So 6 minus 2, that's 4. All right. Then the value of x for which f of x equals what? Equals x. This is our f of x here, 6 minus x. So they are saying take that f of x, 6 minus what? 6 minus x as it is. Equate it to x. So you have formed an equation where you can solve for what? Where you can solve for x. So let us solve for x. We can take it to the other side. It's going to be a positive. 6 is equal to x plus x. So 6 is equal to 1 plus 1. That's 2x. Divide by 2 as we have got a product here. So we're going to divide by 2 to have the value of x. 6 divided by 2, that's what? That's 3. So that is the value of x for you. X is equal to what? X is equal to 3. All right. Number 16, we are given two cylindrical buckets. They are cylinders that we are referring to, all right, are similar. So this is part of your similarity. The larger bucket has got radius, height and diameter. So that is, there is the larger and there is a smaller one. So from the larger, we are given the height 30 centimeters and the base diameter 16 centimeters. The smaller bucket has a base diameter of what? We are given the diameter there of 8 centimeters. That is what we are given. The height is not given for this one, right? Calculate the height of the smaller bucket. That is the one that they want. So this is similarity, guys. We can use what is complete between these two similar figures, which is what? The diameters, to find the ratio of sides, which is what? The scale factor ratio of what? Ratio of sides. We are dealing with what? With the sides here, height. It is the what? We're talking about sides. So the ratio of sides, that's your scale factor. So from what is complete, the diameters, the diameter of the larger one, 16 as to what? As to 8. So we can reduce it by what? By 8 by 8. That's going to be 2 as to 1. So this is our ratio. 2 centimeters as to 1 centimeter, the ratio of the larger to the what? To the smaller one. So to find now the height, we can use this ratio, which is what? Our scale factor. Because we are simply saying from this, the larger cylinder with a ratio of 2, it has got a height of what? We do not know. But the smaller one with a ratio of 1 has got a height of what? We know. Sorry, we are asked the one of the smaller one. We know this one of the larger one, the height is what? 30 centimeters. Sorry for that. The height is what? 30 centimeters. What about the height of the smaller one? This one, which represents what? The smaller one. What is its height? We do not know. So 1 is less compared to 2. So that is simply going to be 1 over 2 times what? 1 over 2 times 30 centimeters. So 30 divided by 2, guys, this is 15. Half of 30 divided by 2. That's simply half of what? Half of 30. All right. On the other part, the volume. So here they're talking about volume. You must work with the volume factor. Remember, we had a scale factor 2 as to what? 2 as to 1. That scale factor 2 as to 1 was used to calculate the sides. But as you consider volume, you must have the volume factor. Remember, you simply cube the scale factor 2 to the exponent, 2 to as to 1, we raise to the exponent of what? 3. So that's 2 to the power of 3, which is 8, as to 1 to the power of 3, which is 1. So remember, this is for the larger. This is what? The smaller. So this is our volume factor, which can be used to answer volume questions. As you are under volume, the volume of the smaller bucket is this. The smaller one, which is a ratio of 1 according to volume. Its volume is 754 cubic centimeters. Calculate the volume of the larger bucket in cubic centimeters. The larger bucket has got what? A ratio of 8 according to volume factor. What is its volume? We do not know. So this is going to be more. Comparing 8 and 1. So that's 8 over 1 times this. 8 over 1 times 754 cubic centimeters. So guys, you can simply multiply this. 754 times 8. You're going to obtain 6,032 cubic centimeters. Multiply properly. All right, so that is what you're going to have for 3 marks. All right, let's see. Number 17, we are given. All right, this survey, sciences, those commercials and arts, it's a survey for some A-level learners. Were asked which of the 3 categories of subjects, commercials, sciences, arts, they were studying. The results were represented in a pie chart above. Calculate the percentage of learners who study what? Arts. So let us focus on the angle first. This one is 216 degrees. This one is 96, right? This one is 96 degrees. What about the arts in terms of the angle first, before we talk about the percentage? So for arts, we know that the whole survey, this whole pie chart, equates to what? 360 degrees. So we subtract these two, 216 for sciences, and what? The 96 degrees for what? For the commercials. So that was going to be 360 minus 216 plus this, which is going to give us something like 312. Then subtract, that's 48 degrees. So this angle here is 48 degrees. Let me just confirm if this is going to add up to 360 degrees. Let's quickly have this. All right, 216 plus 48 plus 96, 360, yes. So let us now consider here, they are asking about the percentage of learners who study arts. So you take them, how many, according to the angle, it is what? 48 degrees over the total of everything, which is what? 360 degrees. So you divide by the total in terms of the angle, 360 degrees. Since we want a percentage, always multiply to what? 100% to obtain that percentage. So that was it. All right. So here's just a matter of reducing, playing around with numbers. All right. So the 0 and the 0 is going to cancel. All right. Let's simply multiply 10 times 48. 10 times 48, that's 480 over 36%. All right, let's try to reduce. Which number can we use? All right, let's work with 4. 4 into 36. So it's going to be 36 divided by 4, which is 9. And 4 here, that's 1, 2, 0 by 3. 3, 4, 0. All right, 40 divided by 3. 3 into 4. That is going to be 1. All right, let's divide here. 3 into 4. We are now having 40 over 3. 3 into 4, that's 1. Remainder 1. Into 10, that is 3. Remainder 1 over 3. So let's just use 1 over 3%. All right, or you can have it as a decimal, but let's just have it like this. So it's 13 and a third percent. That is what you are given. Then here, find in its simplest form, right? In the form m as to n, where m and n are what? Integers. The ratio of number of learners, sciences to what? Commercials. So those who are studying sciences to commercials, we can simply use these angles as they are here. Sciences 210, commercials what? 96. I mean 216 and 96. 216 for sciences. All right, as long this is the same degrees, and the other one you're using also an angle in degrees, which is what? 96. So simply divide by 24 degrees. You're going to obtain 4, and this was going to give you 9. Or simply reduce by the small number, small, up to the last one, simply like that. All right, so that was our ratio that you're going to have from there. All right, then given 44 learners study commercials. Calculate the number of learners who took part in the survey. So this is the total of them all that we are given. So simply take 44 learners representing commercials. What is the angle that we are given for those ones? For commercials, the angle is what? 96 degrees. So the total now number of learners, we do not know them, but we know the angle. The total in terms of the angle is what? 360 degrees. So you can simply use our proportion as we can get more here. So 360 over what? 360 over 96. Then you multiply to what? 44. So I want you to reduce this. You're going to obtain 165 learners if you reduce this one properly. So please do reduce by the smaller number, and so on up to the final answer. All right, so that is how we can play around with these typical questions. All right, number 18, we're given this triangle is got sides of length 6 and 5 centimeters. The angle between these two sides, there's an angle between the two sides. So that's in what? Included angle, the angle that is found in between what? Two sides of a triangle being 120 degrees. So there are two sides that you're given, one here and another one. So we can say 6 centimeters and another one 5 centimeters. That is what you're given. All right. Use as much of this information given below as is necessary. Calculate the area of the triangle. So area of a non-right angled triangle can be determined using half of AB sine theta or sine C, the angle in between, which is what? The included angle. This C here is what? Our included angle, the angle that is found in between the given sides, which is 120 degrees. So that was going to be half of A and B, that are sides that you're given, forming the angle 6 and what? 6 and 5 times the sine of that angle, 120 degrees. All right. So if you check paper 1, you do not have a calculator. You do not have what? A calculator. So you're going to have 15 sine of 120 degrees, but you do not have a calculator. If it was paper 2, guys, I was simply going to take the calculator like this. 15 as it is, 15 sine of what? 120 degrees. I obtain the answer, this one. This is what I'm going to obtain. But I do not have a calculator. This is what? Paper 1. So that is why you're taught to use this information. And from that information, you do not have sine 120. You are given sine 60. Why are we given sine 60? Because of the relationship between the obtuse and what? Acute angle. Remember the relationship between these, that an obtuse angle here that is going to lie in the second quadrant where sine is positive. It follows that the obtuse angle here, the sine of that obtuse angle is equal to the what? To the sine of the acute angle. All right? Because of what? The quadrant where it lies, sine is positive. It is only sine. Cos is going to be negative. Tan is going to be negative. So here the sine of the obtuse angle 120 is our obtuse angle here. So the acute angle on a straight line is what? 60 degrees. So for sine, they are simply the same. Remember that relationship that I talked about. Check the playlist on the trigonometry, all right? So you simply use the sine of what? 60 degrees. They are exactly the same. So that's 15 times the sine of what? 60 degrees, which you were given there, 0.866. So that was it. You're going to multiply and obtain your answer, all right? 0.866 times what? 15. 0 here, 6, 6, 8, multiply by 5, that's 30. 30 plus 3, 33. 40 plus 3, 43. Then we add 0, 9, 9, 12. All right, how many decimal places? 1, 2, 3. 1, 2, 3. 12, comma 99. So this was going to give us 12, comma 99. All right, this is area in what? Square units, square centimeters. So you see, guys, multiplication as well, you must know multiplication of decimals. Those are the basics, all right? So that was what you're going to obtain. You can see it is the same answer using the sign of 120, 12.99. But there, you're in paper 1, and they do not want you to use calculators. They want you to know the relationship between these two. So that is where it plays a role. Right? Then the length of the third side, leave your answer in what? Set form. All right, the third side is this one. This is the third side. As you can see, you're given two sides and an included angle. So we can use what? The cosine rule. All right, so remember the cosine rule can be used in that condition. A squared is equal to B squared plus C squared minus 2BC cos of A. A side calculated, A the included angle opposite to that side. So we are going to simply use that A squared is equal to B and C. Those are the sides forming the what? The angle of 60 degrees, 5 and 30. 5 and 6. You simply square those two, 5 and what? 5 and 6. Minus 2BC, the same sides, B and C, but being multiplied by what? By 2. So it's 2 times 5 times 6. Cos of A, that included angle, the one that faces the side that you're calculating, the 120 degrees. So it was supposed to be cos 120 degrees. But remember what I said, you do not have the angle of 120. So you use the equivalent to that. All right, 5 squared, that's 25, plus 6 squared, that is 6 times 6, that is 6. 2 times 5, 10 times 6, that's 16, times the cos of 120. So the cos of 120 is obtuse. 120 is obtuse. So you take the acute just like here, sine of 60. But as for cos, it becomes a negative. The cos of an obtuse angle is equal to negative cos of what? The acute angle. So you take the acute angle, this one, cos 60, but with a what? A negative. Cos is negative in the second quadrant. So that's negative what? Cos 60 degrees. All right, so that's it. A squared, simplify what you can simplify. A squared, 25 plus 36, that is 1161 minus 60 times negative cos 6, that's negative cos 60. The cos of what? 60 degrees is what? 0.5. So that's negative what? Negative 0.5, like that. So you can simply evaluate that. All right. So that was going to be a squared is 61 minus times minus, that's a positive. So this is under a product, minus 160 and minus 0.5, that's a product. So negative times negative, that's what? A positive. 60 times 0.5, 60 times 0.5. 0.5 is a half, so it's half of 60, which is what? Which is 30. So a squared is equal to 61 plus 30. All right, so you simply add 61 plus 30 here. All right, so here, guys, yes, that's going to be 91. Okay, so here it was cos 120, but that cos 120 is, it's a negative now in the second quadrant. So this becomes a positive at the end. And in said form, introduce square root, square root. So that length representing is going to be square root of what? 91. All right, 91. Can this be simplified? Square root of what? 91. We do not have factors. We have factors there. If we have factors, fine, that is in simplest form. So this one cannot be simplified. You simply leave your answer as it is, like this, in what? In said form under the square root. Under the what? Under the square root. That one cannot be simplified. So that is what we had. Number 19, you are given the point A, the point B, the point C. So check the playlist. I talked about these vectors from your form 3. All right. So they are taken relative to the what? Origin. As taken from the origin, we obtain position vectors OA, OB, OC. Those are what? Position vectors from the origin. You obtain what? Position vectors. So A, find the magnitude, that is, of vector OA, and leave your answer in said form. So let's start by finding vector OA. OA is simply from that point A, just write it in what? In column form. So that's 2, 2, like this, right? From the origin, 0, 0, from the origin, it does not affect that. You take the point as it is, all right? So that's our vector OA, but they were asked what? The magnitude of that. So the magnitude of the vector OA is the square root of x squared plus y squared, where this represent x and this represent y. So that's the square root of 2 squared plus what? 2 squared. And you're asked to leave this answer in what? Said form. 2 squared, that's 4. 4 plus 4, which is what? Which is 8. So square root of 8 in the simplest form, that's going to be 4 times 2. Square root of 4 times 2. Square root of 4, that's 2. Square root of 2, that remains as what? Square root of 2. So this was going to give us 2 square root of 2 in the simplest form. Remember the said form concept, or you express them, you express the number as a product of its prime factors to write this answer in what? Simplest form. By 2, 8 divided by 2, that's 4. By 2, that's a 2. By 2, that's 1. So you can see that there is a pair of 2. So the pair, you write it outside of the square root. The number without a pair, you write it inside the what? The square root. So this was the same answer as before. So you can have that in what? In a said form. So then BC in terms of what? K. So vector BC being a displacement vector can be taken from what? From the position vector C minus B. So that's C minus B, which is vector OC minus vector what? OB. So vector OC is the point C from the origin, the point C, 3, 2 as it is. The point C as it is, 3, 2 as a column, minus OB as it is in what? In column 0K. So that's 0 what? 0K. So let us subtract 3 minus 0, that's what? 0. 3 minus 0. 2 minus what? 2 minus K. So 3 minus 0, that's a 3. 2 minus K, you cannot simplify that. So it remains like this as it is. So this is our vector what? Our vector BC. All right. Then On C, the value of K, given that OA is parallel to BC. Vector OA and vector BC, they are parallel. This is BC, this one, all right? And our vector OA is what? 2, 2. This was our vector OA, which is 2, 2. So vector OA is what? 2, 2, like this. Then these two, they are parallel. So what is the relationship between parallel vectors? You must know that if two vectors are parallel, if OA is parallel to BC, they must be related by a constant if they are parallel. So you can choose any constant of your choice. So OA is equal to, since we have K already, we cannot use K, we can choose another constant, maybe H. So vector OA is equal to H times what? Vector BC. If two vectors are what? Parallel. Therefore, one has to be multiplied by a constant to give another. So let us use this relationship. What is vector OA? 2, 2. It must be equal to H, a constant, times what? Vector BC, which we have already, 3, 2 minus K. So using this relationship, we can form an equation. Say 2, 2 is equal to H times 3, that's 3H. H times 2 minus K, that's 2 minus K times what? Times H. So we can use this relationship to equate these vectors. So, I mean, to equate them corresponding elements. Here, 2 is equal to what? 3H. So you can solve for H. 2 is equal to 3H. Then you can solve for H, which is our constant, the constant H. So simply divide by what? By 3 here. So H is equal to what? 2 over 3. So if H is 2 over 3, use this now to find what? To find the value of K from the second part of our vector here, because we are saying this 2 is supposed to equate to this one. So we can form an equation from the second part, from these corresponding elements. 2 is equal to what? 2, all right, sorry, here I'm using something else. I'm supposed to use this. So 2 is equal to what? 2 minus K into what? Into H times H, this one, all right? So H is what? 2 over 3. We already calculated that. So simply substitute that. 2 minus K times what? 2 over 3. So solve for what? Solve for K. How can we get rid of this 2 over 3? Multiply by the reciprocal is simply interchange. All right, multiply by the reciprocal, 3 over 2, 3 over 2. We are now solving. So this cancels, you remain with what? 3 here. So 3 is equal to, this is 1 times this, 2 minus K. We need to solve for K, take it this side. So it's gonna be what? K is equal to, take the 3 to the other side, that's 2 minus what? 2 minus 3. So K is equal to minus 1. So that was it. So this is the value of K that will make the two vectors to be what? Parallel. K is to be equal to what? Minus 1. Okay. Then number 20, solve this equation A, all right, from your indices. Just make sure that the bases are the same. 8 to the exponent of x plus 1 is equal to 32. So which base can we use? They're supposed to be the same base. Use the same base, and it must be the simplest base. So 8 and 32 can be taken to the base of what? 2. So 8 in the base of 2, that's 2 to the exponent of 3. All right. So 8, 2 to the exponent of 3 into what? X plus 1. Already you are having this exponent of what? X plus 1. Then 32 in the base of 2 is 2 to the exponent of what? 2 to the power of 5, which is what? 2 to the power of 5. So since the bases are the same, equate the what? The powers that you're given. So you simply equate this 3 into x plus 1 to what? To 5. You have formed an equation that you can solve for what? For x. That you can solve for x. So here simply solve for what? Simply solve for x. 3 times x, that's going to give us 3x. 3 times 1, that's 3, which is equal to 5. So let us solve for x. This is a linear equation. We are dealing with what? A linear equation. Take note how do you solve your linear equation. 3 to the other end becomes a negative 3, or simply subtract what? 3 both sides. So 3x is equal to 5 minus 3, that's 2. This is a product, divide by 3, divide by 3. So x is equal to what? 2 over 3 at the end. We can say that x is equal to what? 2 over 3, just like that. All right. Number B, the part B, the log of this, simplify the logarithm of 36 over the logarithm of, this is 1 over 6, okay? 1 over 6. Right, this one is easy. We can just write in the same base, use what? Same number in terms of these logarithms, not base, but same number as they can be related in the same base. You have 36 and what? 1 over 6 in the same base. It is the logarithm 36 in the base of 6. That's 6 to the power of what? 2. 6 squared. 6 times 6. 1 over 6, remember this one can be written as what? To the power of minus 1. X to the power of minus 1 is 1 over x. So that is 1 over x reverse. So that's log of 6 to the power of what? Minus 1. Then you can drop the power from the log p log m equal to the logarithm of m to the power of p. So when you're given a power, you can drop the power on a log. So you can drop this power. It was going to be 2 log 6 over what? Also drop this power. So it was going to be negative 1 log 6. So the log 6 and log 6 can what? Can cancel, as they are the same. They are the same. Log 6, log 6, they can cancel. So you have 2 over what? 2 over minus 1, which is negative 2. So the whole resultant of what we're given here gives us what? Minus 2 when it is what? When it is simplified. This whole part gives us what? Gives us negative 2. So that's how you can play around with your logarithms. For number 21, you're given this shape. All right, the diagram shows triangle ABC. ABC is a triangle in which AC, this is our AC, equal to what? BC. These two, they are equal. So remember, from these equal sides, opposite sides, the sides that are opposite, these equal angles, these equal side, these angles, I mean, this angle and this angle that are opposite, equal what? Equal sides. Those angles will be equal. So meaning to say the angle at B and the angle at A here will be equal. So this was y degrees. So this one also is going to be y degrees at B. All right. That is angles opposite what? Equal sides. All right. That is what we can take from there. And we are given point D on AC produced. AC is produced. So AC is a straight line. All right. And DE parallel to what? This line DE is parallel to BC. We are considering parallel lines, and this angle is X. Remember, they said to AC produced. So this is a straight line. Angles on a straight line add up to 180 degrees. So you can find this angle on this part of C, the other angle on C here, from 180 degrees, subtract 108. And that was going to give us what? 72 degrees. All right. Okay. Calculate the angle marked X and A, the angle marked X, this one. So X, you can take it from these corresponding angles, since we are forming the letter F. Those are corresponding angles. One is inside, one is outside of the parallel lines. So corresponding angles are what? Are equal. So angle X is going to be 72 degrees. Or you can calculate from in within these out, I mean this in our parallel lines, considering our co-interior angles in within the what? The way we are forming a C or a U like this inside, these are co-interior angles which add up to 180. So the angle of 108 plus this angle of X degrees supposed to give us 180 degrees. All right, that is co-interior what? co-interior angles. All right, so you can solve for x from that. So x is going to be 180 degrees minus 108, which is going to give us the same as before, 72 degrees. So many ways. There are so many ways that you can answer this type of a question. All right, then let us consider y there, the value of y. So from that y that we have, we can take it from here. Angles, net triangles, since they add up to 180 degrees. So you can use the 72 degrees. Since these two angles are equal, so y is simply going to be taken from, you take this from 180 degrees angles in a triangle minus 72, then divide by what? By 2, since y and y, they're equal. So you form an equation. So you're going to find the value of y from there, or you can use the exterior angle concept. 108 is the exterior angle. It is equal to the sum of the opposite what? Interior angles. So y plus y is equal to 108. All right. That is the sum of what? Interior angles. Opposite interior angle is equal to the exterior angle. So 2y is equal to 108. Another way. So simply divide by what? By 2 by 2. So y is equal to what? 54 degrees. So that was another way. So many ways, guys. All right. So y there was going to be what? 54. So you can simply play around in that manner. All right. It's just a matter of playing around. Then another one was N on C. N is here. This is angle N. So remember, we've got the value of y, which is what? 54 degrees, 54 degrees. So N being on a straight line, you can simply consider angles on a straight line. So 180 minus what? 54. So N 180 minus 54 degrees angles on a what? Angles on a straight line. So that was going to give us 120 what? 126 degrees angles on a what? Straight line. I'm just going to write in short, angles on a straight line. Okay. So that is it from what you're given. Number 22, you're given a bag which contains X red balls, right? 8 green. So X are red. Then 8 are what? Green. The probability of picking red is given, or this part red probability is given as 3 over 5. All right. A, find the probability of picking the green ball. All right. So they're just having two things to consider inside the bag, red and what? Red and green. So these two, their probability must add up to one, must add up to 1. The probability of picking red and that of picking green should give us a 1. So the probability of picking green is the one that we want. So probability of picking green is simply 1 minus the probability of picking what? Red. So probability of picking green is going to be 1 minus the probability of what? Picking red, 3 over 5. So that's it. 1 minus 3 over 5, simply in the what? In the denominator of 5, 1 is same as what? 5 over 5 minus 3 over 5. So 5 minus 3, that's 2 over what? 2 over 5. So the probability of picking green is 2 over what? 2 over 5, just like that from what you're given. All right. Then another question on 22 was to find or to calculate the number of what? Red balls in the bag. If we are given, because we are given its probability, but we do not know the total. So we can use what? The green balls, because we know there are 8 and its probability is what? Is given. So we can use the green, since green balls, there are 8 of them. So we simply say that probability of green, it was taken the 2 over 5. It means 2 over 5 times what? Times total is equal to the number of 8, which is the green balls. So from what? From probability of what? Green balls. So 2 over 5 times the total. What is this total? We do not know. So how can we get rid of this? This is 2 over 5 multiplied by 5 over 2. The reciprocal multiplied by 5 over 2. This cancels. So our total can be obtained. 214 times 5, that is what? 20 balls. So we have got a total of what? 20 balls. So what will be the number of red if its probability is what? 3 over 5. If its probability. So to find number of red balls, simply take its probability, which is what? 3 over 5. So it's simply 3 over 5 times the total or number of balls times what? The total number of balls. That is it. 5 and 5, 1 into 24 times 3. That's what? That's going to be 12. So we are going to have 12 red balls. So that is the condition of how we can attempt that typical question that we are given. All right. Then on the other hand, if two balls are picked, right, two of them are picked random, one after the other without replacement, find the probability that they are of the same color. So the probability of the same color we can consider. Remember that we've got red and what? Red and green. So red, green. This is the first pick. Then another one was going to be red, green. This is it. Yeah, red, green. So from what we are given, guys, without replacement, we have got the first pick. The first pick is the one from what we are given, those probabilities to say the green is what? 2 over 5. Red was 3 over 5. So you take those ones as they are. Red, 3 over 5. Green being what? 2 over 5. So here, to have the same color, it's red to red, green to green. You can just focus on that, or you can fill in. It's not a problem. All right. So 3 over 5, you pick again. You are going to reduce from that. So that's 2 over 4. Remember, without replacement, the total is affected. But green is not affected. It's what? 2 over 4, of which is not important, this one, because we do not need it. All right, green to green, you pick the green, you pick another green. So you'll be left with one green there out of what? Out of 4. The total is affected, but red is not affected. There are still 3 as they were out of what? 4. The total is affected, though we do not focus on this part because we need the same color, red to what? Red to red, green to what? Green to green. That is what you're simply going to need on that probability. So probability of red, red plus probability of what? Green, green. What is red to red? First, it was 3 over 5. Then the second one had to change. You take 1 from that. So out of 5, you take 1, you remain with 4. The total here is also, the number is also affected. The green to green, this one times this one, or you can even analyze direct to say I was having 2 over 5. I pick again, so it'll be 1 over what? 1 over 4. Or you can use the diagram like I said there. All right, so let us multiply. We can simply consider numerator to numerator, denominator to denominator. 3 times 2, 6, 5 times 4, 20, plus 2 times 1, that's 2, 5 times 4, that's 20, so that the denominators are simply the same. All right, we can see that they are simply the same. So we can add the numerators together. All right, 6 plus 5, which is what? 6 plus 2, which is 8, over the same denominator of 20. So reduce this one by 4. That is 8 divided by 4, that's 2. All right, divide by 4, divide by 4. 20 divided by 4, that is what? 5. So this was going to give us 2 over 5 at the end. Okay, so that was the condition, how to attempt this typical question that you're given. All right, that was the condition. So this was the last question, making it to be out of 100 marks. All right, so guys, please do revise as much questions as you can in what? In light, preparing your examinations. And for those who feel like I did not participate, very like you didn't perform well in these examinations that we're having or that we're writing, start preparing now. Do not wait for a time to come when you receive the results. It is better for you to receive those results while you are already preparing, you on the preparation. All right. So let us do revise. If you let's say you passed the exam, then it's fine. It was a benefit to you. You were understanding more of your mathematics, all right? Then if you failed, then it's also an advantage because at that moment, you do not need to start from scratch. You have been revising those topics. So it is just adding to the information that you already have. So do not stop revising. Do revise as much as you can as you are preparing for the exams that are ahead of time. So this is it, guys. Till we meet again.